Yo, what's going on, guys? Rich Cardi here, coming back to you guys with another video. In today's video, I'm going to be teaching you guys how to take the log of negative numbers, because there's not a single video on YouTube that does tell you how to take the log of negative numbers. So right here, I have the polar form, e to the theta I equals cosine theta plus sine theta I. You could look up proofs online of that. I'm not going to fully explain it, but just know it exists and it is correct. So what I want to get out of this whole process is the natural log of I, because if I take the natural log of I and I set the inside to I squared instead of I can find the log of negative 1, because I squared is negative 1. So anyways, what I have here is I'm trying to basically get I on one side. So the way I do that is I set theta equal to pi over 2, and when I do that, cosine is 0 and sine is 1. Because also, I can show you on this unit circle right here, pi over 2, get a cosine value of 0 and a sine value of 1. It shows all the cosine sine values around the entire circle. So, yeah, e to the pi over 2i equals I. So, take the natural log of both sides. Natural log of e is 1. So, basically, take out the 1 here, and then what you're left with is pi over 2 times I. So when you take 1 here, you take the pi over 2 and the I, and you put them over here, and basically multiply it times 1. So, yeah. And of course, you have to take the natural log of the other side. So you just bring these exponents down to the front. You get pi over 2i is the natural log of I. So, down here in this jumble of signs, I'll zoom in on that one. What I have here is it shows that 2 ln I equals ln of I squared, because you take the 2 out and put it in front. That's just one of the laws. And also, of course, I squared is equal to negative 1. So 2 ln I equals ln I squared equals ln negative 1. And here, I really poorly notated this, but basically I'm multiplying ln I times 2 to get the natural log of negative 1. And if you recall, that is the natural log of I. So multiply that times 2, and we get pi I. So, therefore, natural log of negative 1 is pi I. So, how about the logs that have different bases than e? So here I have the common log, just log base 10. So I just pretty much skipped all the steps, so starting from here, basically, you could read across and they have the same starting point. Well, this one starts later, but we already know that to be true. So the log of I, we have I on that one side, so that's really good. So we take the log of both sides, and we get the log of I is the log of e to the pi over 2 times I. And this time, we're going to take out the exponents once again, bring them out to the front. We have pi over 2 times I equals log of e, which is equal to log of I. I don't know if I just said pi over 2 times I is equal to log e, but it's not. Just a slip of words. 2 log I is equal to log of I squared, because you take the 2 and you put it on front, property of logarithms, and that is also equal to log of negative 1, because I squared is negative 1. And we already know what log I is, so we just multiply it times 2, and here is log I right here. When you multiply it times 2, the 2 on the bottom and the 2 on the top would cancel. Yep, basically, see it right there, the 2 would cancel right there, and you're left with pi times I times the log of e. Therefore, the log of negative 1 equals pi times I times the log of e. And here I just have some basic examples. Ignore this for now. It doesn't have an answer right now, but so we have the natural log of negative 1,000, and you can split that up to negative 1 times 1,000, of course. And the property of logs is if you multiply them together, you can add them and separate the logs. So natural log of negative 1 plus the natural log of 1,000. So we don't know what the natural log of 1,000 is. God knows who it is. what it is, not who. But we do know what the log of -1 is. It's pi I. So the reason I say it's not very useful is because you end up with an imaginary number at the end of the day, most times. But I'll show you where it doesn't. So the log of -1000 is, I mean, you can basically see through it. It's all you do is add a log of e, and the reason there's no ln of e at the end here, or I should say log base e of e, because what we're doing here is we're taking the log of e using the base that it is used for everything else. That's log 10, log 10, log 10, log 10. So yeah, this one is log base e, log base e, log base e, log base e. So then it would just be log base e times e, or log base e of e, which is just 1. So that's the reason we don't have that at the end. So now we get to this, which is quite an interesting example, because those of you who are very familiar with logs have figured this out by the time the video began. But what you can do here to solve the equation is you can actually use two methods. One method I know probably none of you have seen before, but this method is simplest. So we got 10 to the, we raise everything to the base of the log. So 10 to the log of -x is equal to 10 to the third. That's a 3, so yeah. 10 to the log base 10 is 1. 1 times -x is -x. That's a negative. I don't know why I'm drawing so poorly right now. 10 to the third is 1 with 3 zeros, 1,000. Therefore, x is equal to -1000. So, I mean, that's pretty simple, right? Well, let me show you how to do it the most unnecessarily difficult way. It's not very difficult, but I mean, as you get to higher order logarithms, it's going to get extremely impractical, or maybe even be practical in some situations. So, let's just write it down. Or, log base 10 -x equals 3. So we're going to split this up. Log -1 times x equals 3. Log of -1 plus the log of x, that's the basic property of logs for multiplication, is equal to 3. What is log of -1? Let's go back here. Log of -1 is, sorry about that, pi I log e. Then you gotta add your log x. Of course, that's going to be undefinable right now, equal to 3. And we want to get the x on one side and everything else on the other side. So let's keep the x there, keep the 3 there, and let's subtract pi I log e from both sides. And now that is our terrible, beautiful equation. If you guys are familiar, like very familiar with logs, you know this is going to be weird, but trust me, it's really not. So let's raise everything to the base. So this is log base 10. So 10 to the log base x, or 10 to the log base 10x, equals 10 to the 3 minus pi I log e. You probably think this is impossible if you're not familiar with logs, but this is actually quite easy, but it's also kind of a cool little observation you can do. So this, of course, right here was meant to give us x, because 10 to the log base 10 is 1. So x equals 10 to the, yep, that's a thing. It's really not as hard as it seems. I'll show you a quick law of exponents that'll definitely get you more confident. So 10 to the x plus y is actually equal to 10 to the x times 10 to the y. So that should definitely make you more confident in doing this one. As you can see, it's if you are witty, you'll be able to figure out what the result will be. But yeah. Also, it's kind of cool to relate them and say, this is equal to negative 1,000. And what's cool about this is 10 to the third is what? 1,000. And then you have this little extra bit right there. So what this extra bit right here is basically, it's going from an exponential form, but it's putting a negative 1 in front of the problem. So I'm not sure the exact use for that, but I just thought it's pretty cool to think that an exponent can put a number in front of your whole expression. So that's pretty cool. So anyways, let's get to the bottom of this and prove that that's the case. So we got x is equal to this just terrible number. What we can do is split it up to 10 to the third times 10 to the negative. That's key right there. But you'll see that it actually doesn't matter at all. So it is equal to that. So let's simplify this a little bit. X equals 10 to the third, 1 with 3 zeros in front, or in back, times 10 to the negative pi I log e. So you might be getting nervous about this one, but trust me, it's really not bad. So x equals 1,000 times 10 to the... Now what is this? What is... You should be able to identify that pi I log e is what? It's the log of negative 1. So this is negative log of negative 1. So this becomes all of a sudden a very approachable problem. This negative might concern you, but here, negative 1 times log of negative 1 is equal to log of negative 1 to the negative first power. Well, that's just this. And what does that equal? So, it really doesn't matter, and these are parentheses. So, at the end of the day, you could say plus or minus log negative 1 equals log negative 1. Not sure if that's a unique trait. Actually, it is a completely unique trait for negative 1. So, yeah, that's also pretty cool, because you can't do that with any other number. Alright, so what we have here is a very approachable problem. So x equals 1,000 times 10 to the log of anything is 1 times what is on the inside, which is negative 1. Well, negative 1 to the negative first power, which is negative 1. Well, 1,000 times 1 is 1, times negative 1 is negative 1,000. And this matches up with that. But you should be able to notice the extreme difference between, like, what is that, 12 steps and 3 steps. So, I mean, it's definitely a cool thing to explore. I'm not sure the exact uses of this, to be honest. I just kind of came up with this whole concept and thought it was pretty interesting. I thought I found a paradox at one point, actually, but because I didn't think that this came to negative 1,000. I thought it came to 1,000 times something. That was weird. But anyways, that's the video. Also, for all of you that say the natural log of I and the log of I is a multi-valued function, I know it is, but I'm not going to mess around with that because I'm not very good at that kind of stuff. I don't understand it very well. So if you guys could get in on the comments, that'd be good, but it's really not necessary for this. In fact, it actually is more cumbersome to include that variable. So yeah, anyways, I hope you guys got something out of this. If you didn't understand a part, I can definitely help you. I kind of came up with this on my own. So yeah, thank you guys for watching. I'll see you guys in the next one.